Okay, so this interest, we have a formula, and I'm going to always have this for you. Interest equals the principal, which is the money you start out with, times the rate of, and when you do the rate, you always turn the percents to decimals, and time is in years. Okay, so looking at number 1, you invest $600 in a bank account, 2.8 interest. How much will you have after 9 years? So interest equals the principal. So we start with 600 times the rate, 0.028. Okay, every time you're moving that 2 places. Times 9 years. Okay, so this is just a straight calculation. Just go, go, go. So this one says how much interest. So I'm going to earn $151.20 of interest in 9 years. That is like really high. I would say that's, you probably won't even get that much interest these days. Okay, you invest $5,000, 3.2 interest. How much money will you have after 4 years? So interest equals P R T. So the principal times the rate and then the time. So the interest I earned was $640. And you times it. Did you get that? Okay, but that's not your answer. Okay, you have to be very careful with what I'm asking you. How much money will you have now? So what kind of total amount of money do I have? So now I'm going to take what I started with, and I'm going to add the interest that I made. Okay, so be careful with the questions. I might either ask for interest or total. Okay, you invested $15,000 for 6 years, and now you have this much money. What rate did you invest at? Okay, what I'm going to do is right now I'm just going to write down the formula. And let's see where we could fill everything in. We're looking for the rate this time. Okay, you invested $15,000. I invested $15,000. So that would be, that's my principal, right? That's my starting. I already know that I'm trying to figure out the rate. And in 6 years, so that's my time. Now you have this much money. So that's a final amount of money. So could I put that there? No, that's not my interest. Okay, so again, on these questions, interest versus the final amount. Okay, know what's what. So the interest will be the final minus the start. So how much did I gain Whoops, why didn't I put 60 in here for the time? Okay, so there's the trick with this one. Understanding that 16,710 was not your interest that you made, okay? So when I type this into my calculator, this is what I would be typing. That's exactly what I would type in my calculator. So I'm showing you brackets on that because you have to put brackets. Okay, see what you can come up with. Okay, you're investing 3% 4 years. What is the return on your investment? Okay, so when we do our formula, we're going to do principal is 2,000. The rate is 0.03 for 4 years. Okay, on your formula sheet that you would get from the start of the year, there's some crazy formula that says what to do here. Oh, here. Interest divided by principal times 100. I think that would be on your formula sheet. Okay, I'm going to just state this formula very plainly. So the rate of your return is going to be this. The money you made divided by the money you would have had to put into this on your own. Okay, so in this case, $240 was the money I made, like the bank. The bank just gave me that money. I didn't own that money before. So $240 is what I made, and I had to put in $2,000 of my money to do that. Okay, so that's what I'm getting, 0.12. So I'm going to state that as a 12% return on my investment. So this one has to be expressed as a percent. Did you notice how on this one I answered the rate like that? That's acceptable to leave as a decimal. If you did 1.9%, that's also great. But this one, you have to state it as a percent. So 12% return on your investment. Okay, then this other formula now talks about compound interest. So compound interest versus simple interest means that you get interest, and then the next time you do your interest calculation, you do it on the new amount. Then you earn more, and then you get interest on the new amount, and then you get interest on the new amount. Okay? Simple interest, you just get interest on the initial amount. So that's the difference. So I kind of have something for you here. You can see in my chart. So these people both put in $500, which means they both earned $15 of interest. Okay? But on the compound person, did you notice how the next time they're earning interest on $515? So they earn a little bit more. Then the next time they're earning interest on $530.45. So it keeps carrying forward. versus the simple interest person is just always consistently earning $15 because that's what they put in. They put in $500, so it just stays like that. Okay? So compound is obviously going to earn you more money. Okay, so let's see how it works. You invest 4,000, 7 years, 2.8. Compare simple versus compound. So interest equals PRT. So 4,000 times 0.028 times 7. So that's how much interest I earn. But it says determine your total. So then I'm going to make 4,000 plus that. Okay, now we're going to jump to compound interest. So here's this formula. Okay, so A stands for what's the final amount. That's what it's going to stand for. P, what we started with, the principal was 4,000. 1 plus the rate, so 0.028 divided by n. So this says it gets compounded annually, so n would just be 1. So it just gets compounded every year, once a year. NT, if you compound something every year for 7 years, then it would only end up as a 7. So that's what I was doing, once a year for 7 years. Okay, can you practice typing this into your calculator to see if you've been typing it in correctly? And I knew it was going to be more in the comparison than a simple interest, and it did. Does anybody need help finding their exponent button on their calculator? Okay, see what else we can do here. Okay, you're investing 7,000, 3 years, 3.3. Compare if one is going to be compounded semi-annually and one is going to be compounded monthly. Okay, so final equals 7,000, 1 plus the rate divided by, if you do something semi-annually, what does that mean? How many times would you end up doing it in a year? Twice. What would your exponent be? And then here's my thinking. If I do something twice a year, for 3 years. How many times do I end up doing it? 6. Twice a year for 3 years. Okay, can you type that in and see what we come up with? Did we get it? It worked? Same? Okay, the next time we're going to do the same numbers, but this person is compounding something monthly. What's our prediction? Are you going to make more or less money the more often you compound it? What do you think? What should the answer be, more or less? Any guesses? The more times you compound it, the more money you should make. Okay? All right. A equals 7,000. 1 plus 0.033 divided by 12, because you're going to do it monthly. So in a year, that means you're doing it 12 times. If we do this 12 times a year for 3 years, that means I'll end up doing it 36 times. Okay, let's see. It should come out to more than our first one. You need to make sure brackets are involved in your typing. Okay, it's not terribly higher, but it is higher. And that was my prediction. Okay, so you have to know that, by the way. There's going to be questions, there's going to be test questions that just say the understanding of who's going to make more money. The person who compounds more, who's going to make more money, the simple or the compound? The compound. Okay, compare your rate of return. So that is, again, the money made divided by the money that you're going to be putting in. Okay, the money that I make is my interest. So here's the trick with this one. This is opposite. This time the formula gives me final. So what is the amount of interest? So you have to take away the 7,000. So what the bank would have given them was $722.22. That's the money that they actually made as a profit part, right? Divided by, I put in $7,000 of my money. Okay, and then this one always gets expressed as a percent. So 10.3% return on your investment. Okay, next, so can you do the same thing? So how much money did you make, as in how much of this was profit? So 727. And how much did you have to put in to make that? That's good? So be careful with that formula. Understand that formula gives you the final, so sometimes you're going to have to go back and get the interest. Versus the first simple interest gave us interest, and sometimes we had to get final. Okay, we're going to do something different here, and then we're going to have to use our calculator yet, so it'll be our graphing calculator. You invest $9,000 at 3.4% interest compounded quarterly. Estimate the time it will take for you to double your money. Okay, so on the notes page here, there is this little formula that says the rule of 72. So this rule, it's helping us to estimate the time it takes to double our money. Okay, so that's the rule. So 72 divided by the I, which is the interest rate. Here's what I'm going to also tell you at this time. When you see an I and I have 5%, I is 5. If I have 5% and I see an R, then my 5% is 0.05. So I's are the interest as the number, and R's are the interest as a percent, or as a decimal, sorry. Okay, does that make sense? I's you leave, R's you decimal the percent. Okay, so 72 divided by 3.4 is all you do. So it might take me about about 21 years is what I got. So it's an estimate. Okay, determine the actual time it's going to take you to double your money. Okay, so we started at 9,000. 1 plus 0.034 divided by the rate, divided by, and it's compounded quarterly. So I'm going to divide by 4. And the time is what I don't know, but if I do it 4 times a year, how many years? And what are we going to put on this side? What do I actually want to end up with? I'm trying to do what with my money? Double it. So I want to put 18,000 there because that's what I want to end up with. Okay, so like I said, we're going to have to solve this with our graphing calculator. Alright, what I'm going to do is I'm going to be entering one of these equations in y1 and one of them into y2. Okay, here's something you have to remember to do. When you do the exponent, you're going to have a bracket around 4x. I think that we had some of those when we did like our log and exponent unit. You got to make sure if you have an exponent that's doing a few things, you got to put a bracket around it. Okay, probably don't hit graph because it's going to be a crazy looking graph. We already know the numbers involved. Okay, are we okay with this? How I typed it? Window. We kind of already know the answer is around 21. Are you okay on the x-axis if I go to what? 20, 25, I don't know. On the scale, I'm going to go every 5 years. And the Y max, I'm going to go to 20,000 because I want to get up to 18,000. Let's do a scale of every $5,000. Does that make sense? Why I already know that stuff? Because of my money. Ooh, that was almost a drop. Okay, let's see. So there's my money. My money's growing, 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 growing. And I want to know when it hits 18,000. So I'm going to do a what function here? Calculate the intersection. Enter, enter, enter. Let it do the work for us. 20.47 years. So look at how close the estimate was. I think this is kind of in some of these questions. Did you notice how I drew this curve? This is compound interest. Does that make sense graphically? Compound interest grows, 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 right? What would a simple interest look like if you ever graphed simple interest? It would just be just a line, a straight line. Simple is straight, compound, curves, 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 because it's growing exponentially. Okay, so on your test, I know I already put this on there. It's the estimate and then actual. Okay, so there, see the difference in how I did that. So using that word, as soon as you see estimate, that's the 72. So connect estimate with 72 rule. Okay, you invest 7,600 compounded semi-monthly. Ooh, what in the world? Semi-monthly. How many times a year does something happen if it's semi-monthly? 24 times a year then, yep. Okay. So you invest and you earn that much interest. Okay. So 7,600 is in my investment. 1 plus rate is the thing I don't know this time. Divided by 24. And then if I did that 24 times a year for 3 years, that would be a 72. And what is the final money I end up with? So I don't even know that. What do I have to do to get the final money? What I started with plus the interest. Okay, what kind of people are we? Are we jump to our calculator, let it do the work? Are anybody feeling like they want to like algebraically do this one? I knew that you would. I'm thinking you're the only one that wants to, so you go ahead and do that. Make sure you do the 72nd root of. That's what you'll have to do eventually, right? Divide and then take the 72nd root. Okay, are the rest of us just typing this into our calculator? We got to do a y1, y2. This is why everybody's in applied, because then they don't have to do the algebraic work. I will, yeah. Okay, so here's my type. Now, do you understand your window? I'm trying to solve for a rate. Rate's going to be like 0.01 or something, right? Something really small. So let's go to our window. You know what I'm going to do? I'm going to do from -1 to 1. That's as far as I'm going to go on the x. Because I'm solving for rate, and rate is going to be a decimal number, so I don't want my x's too big. Can I do a scale of 0.1? And then the y is the money. What do we want to write as our top money? Should we just do 10,000 as our top money? And you could do like a scale of 1,000 then or something. Okay, so you have to, on these problems, understand my x variables and my y variables so that you can graph. Oh, look how slow mine's going.
Yeah, mine's going.
Yours is going slow too? Yikes. So much thinking it's doing. Look at where it's crossing. It's like 0.0 something. I probably should have even made a different x. To be honest, I probably should have just done 0.1, -0.1 to 0.1, because I knew it was going to be 0.0 something.
We're doing this on a test. Do we have to draw the graph?
No. I'm just trying to show you like what I'm doing. If you draw me the graph, I like that because then I can just see what you're doing. That's like you in pre-calc showing me your algebra steps. Like that's what you're doing. Okay, so now looking back, I probably would have made my x scale even ridiculously smaller. I would have even gone from just a -0.1 to a 0.1. I think that's why it was so slow. Was everybody slow? It was just thinking really hard. So yeah, like I'll just quickly change this here. -0.1 to a +0.1, going up by 0.01s. So if I do that, maybe it'll just think faster. Oh no, it's still thinking pretty slow. Okay. Okay, Kaylee, did it come out the same? You forgot how to do it. Okay.
I only remember how to log it.
I'm going. Oh no, you don't have to because
Well, we did one like this where you log it.
you would have had to do a log on this one. This one is the one you would have logged on because it's
I
a.
forgot, like, I knew square root of 72, but I don't know where that goes on.
You did an algebra?
That's 0.733 instead of 732.
Okay, so I would have divided, right? I would have divided. That's what I would have done.
And then you don't have
That's what I would have done. Then I would have taken the 72nd root of that. So I would have gone like this. 72nd root of that. And gotten a number. Then I would have subtracted 1. So I'm just keeping this all in there. Subtract 1. And then I would have times by 24. So I kept everything in my calculator, just answer, 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 and there I go. I got the exact same thing. Okay? Okay, I'm sure most of us were probably just straight, okay, I'm just going to start graphing and just let the calculator do the thinking.
What do you do
But-
this 70?
I went like this, 72 first, and then the any root of. Are you into your graphing calculator? Oh my goodness, look at it, it's still thinking about that graph. I would go 72 on this calculator, and then there's a button called the math, under the math tab, the any root of. Is that what you found? Math, any root of. And then obviously I would probably have had it typed in already before, so I would be doing my answer.